This is a Möbius strip. You can make this by twisting a rectangular strip once and connecting the ends. What's the minimum ratio of length to width to be a Möbius strip? If the ratio of length to width is 1, meaning the length and width are the same, you cannot twist it. It's impossible to form a Möbius strip. Since it has to be twisted, the strip must be longer than its width. Here is a Möbius strip with a width of 1. Assume that the strip is thin enough to bend and twist in any shape. Now, fold the strip at 3 parts, each forming a 60-degree angle. Consider that the strip is folded so that this triangle becomes an equilateral triangle. From the top view, it looks like a hexagon. Choose one of the 3 sides and cut it down the middle. Then unfold the strip back into its original rectangle. You can see the creases from the folds. Since the strip is folded into the shape of an equilateral triangle, these creases are evenly spaced, and these 2 parts are congruent. Now, here is a shorter Möbius strip. Again, fold the 3 sections and press them down, making 60-degree angles. It becomes a smaller hexagon. Pick one side, cut it, and unfold the strip. You can see the 3 creases as well, but there's a difference compared to the longer strip. The gaps between the creases are smaller, and these parts also become smaller. What if the strip gets even shorter? The gaps will shrink further. The smallest possible gap is 0. At that point, the shape looks like this. The 3 creases are connected. This is the shortest possible length for the Möbius strip, the minimum ratio of length to width. In this case, the Möbius strip takes the shape of an equilateral triangle. Let's find the shortest length. The width is 1. Assuming that the strip is folded into an equilateral triangle, these angles are 60 degrees. Therefore, the remaining angle is also 60 degrees. The triangle is equilateral, and this part is half of the triangle. The lengths of the 3 sides are equal. This length here is what we are looking for. If we call this length x, this length is x over 2, so the answer is x times 3 halves. Let's find x. Since it's an equilateral triangle, this angle is 60 degrees. This line is perpendicular to the base, making this a right triangle. Now, calculate sine 60 degrees for this right triangle. The value is equal to √3 over 2. Solving this equation gives us x. Multiply that by 3 halves. We get √3. So, √3 is the minimum ratio of length to width for the Möbius strip, approximately 1.73. The length must be greater than 1.73 times the width, mathematically.